Hello everyone and welcome to my video. My name is Mustafa Alayawat and my presentation today is about atmospheric water generator. First, I would like to start with this question. How does water go from a gas to a liquid? We see this most of the time on cold surfaces. Like here in this example, both of these cups are the same and both are filled with water. The only difference is the one in the right has ice on it, which make it create a water drops on the surface. This is called condensation. Condensation is when a water vapor, a gas, turn into a liquid water, and that is because of the temperature. When things get cold, the molecules compress, squeeze up closer together, they join together until they create a water drop. That is how we can collect water from air, and this is the purpose of this project. In this slide is the concept design, and here is the device model I created by Autodesk Fusion 360. I created the 3D model just to see how everything is connected together. A cold water will be in the big tank, and from there to the pump, the water pump will pump the water through the pipes and keep going in a circle. I just want to mention something here that the coil part is made of copper. It's made of copper because copper is a good heat conductor and the water is gonna keep recycling to keep it cold. The cold water is going through the tube, the pipe, through the coil just to make sure that the coil is cold enough to achieve the condensation temperature and condense water. Here is a cool picture I found in the web to show how the device is functioning. It's a bit complicated, but it's follow the same concept. The moisture air comes inside and the evaporator create the water. Here in this design, instead of the water pump, they have a compressor because we can replace the cold water with the gas for extreme cold temperature. The process of making this device. I started with the water pump because it was the most complicated part. I 3D printed the water pump and I recycled a DC motor from an old device. I used that to create the water pump. After that, I attached the water pump to a container, a food container, and that's where the cold water is going to be. And I uh, I connected the wire to a battery to the motor. As you see here in this picture, I drill a hole in the container and I glue using a hot glue. I glue the pump to the container. This is the final design after I got everything connected together. You see here is the plastic tube connected to the water pump and from there to the coil, the copper coil, and the water is going in a cycle. And in the second container, the big container, is where the water gonna be gathered. In the right, I tried to use a milk jug, but it didn't work. It failed, so I just used the food container instead. Now is the cool part, which is testing the device. I filled the container with with the water, with the cold water, with ice. I really had to keep the water really cold, and after that I run the pump and the water start going in a circle. Here's a short video of the device running. The water have to flow in the tube to keep the copper cold uh, and a constant temperature. as much as the result proved that the device worked. Even though the collected water was not a lot, I was able to collect 1 teaspoon, which is equal to 4.9 millimeter, after running the device for 2 hours. The amount of water depends on the air humidity. The more humid, the better the result. I ran the experiment in a rainy day and the humidity was 93%. I also tried to run the device in lower humidity day, but unfortunately I wasn't able to collect enough water to be measured. So the best condition to run this device is when the humidity is really high. Here are important variables that influence this experiment. First, humidity. The humidity was 93%, and as I said, the more humid, the better the result. Second thing is the weather temperature. The weather temperature was 12 degrees Celsius, but I ran this inside the house, so the room temperature was 23 Celsius. The water in the tube, which is the cold water, was between 2 to 4 degrees Celsius. The area of the cover of the coil was 94.24 inch square and the water result was 4.93 millimeter. I used AAA battery, which is equal to 3 volts, and the time the device was running was 2 hours. So now is the final question: can we use this device? The answer is yes, we can use this device for agriculture where there is a lack of water, or we can use it for making a drinking water. There is already an existing device to make water. All you have to do is just to plug it into electricity and the water will be filtered and be ready to drink. This can be a really good solution for where it's really hard to find a good source of water. Another great design where we can use the different change in temperature in the nature to collect the fog as you see here in this picture without using any electricity. So this was my project for my thermodynamic and fluid mechanics class. I really enjoyed making this project. It was really a cool idea, and thank you for watching my video. And if you have any question, please write it in the comment. Thank you. Possible. And after running the device for a while, the water drop start to getting bigger and bigger on the surface of the copper.